Continuing on with class 3, this is video 2, class 3 in thermodynamics. We're talking about the tables, the property tables in the back of the book, where we want to try to look up properties. And for water and steam, there you could see kind of the overall idea is placed. Okay, so first off, we have pressure and volume shown over here in figure 2.9. And you can see this is the vapor dome that we introduced in the last class. And you can see that the lines that they're presenting on here are for constant temperature, right? And they're showing here's liquid over to the left, liquid and vapor here in the middle, and we have vapor over to the right. And notice that we don't have solid in there. We're not really dealing with the solids so much in this. And then I just was made a liar. Okay, sorry, I'll take that back. So in figure 210, we could use this as kind of like a how to find the table that you want. And here's my liar right here. If we had the liquid, you could find it in appendix B.1.4, right? Not as useful to us. No, I'm sorry, this is the liquid. I'm sorry, here's the solid. I didn't lie to you about this one. We will need this one. Here's the solid one. We don't really use the solid ones all that much. Same thing over here. Oh, this is even no table right there. See, we don't use solids a lot. But here's for liquid. You might find it in B.1.4. Here's the one that we use the most often. We have B.1.1. We also have B.1.2. All right, both of those contain the liquid and the vapor, and they're indexed differently, right? So one of them is based on temperatures, and one of them is indexed based on pressures, and it's just for your convenience. They don't, interestingly enough, this is for the SI values. They don't do that for the English values, which is kind of annoying to me, but I'll get over it. And then over here we have just vapor. So this is going to be the superheated tables. So a lot of times we'll call these the saturated steam tables, and we call this the superheated steam tables. And then this over here we have alongside. I don't even know what B.1.5 is. We'll have to look. Maybe should we look that up together? There's no table for this, but here's your liquid table, the same one we had over here. You know, they're just telling you here's a P versus T versus and compared to a T versus V, right? And then we have this line right here that they're saying we have these. Yeah, this right here is the saturated tables as we wind up here, and then we also this is the steam tables. All right, so here's like just a little excerpt from the top of them, but I can go ahead and open up a PDF I have of the textbook that was provided to me. But first, let me kind of diagram some stuff out here, right? So let me see. Here are those main tables that we care about. Here's the 1.1. You go to 1.1, and you could see that we have indexed by the temperature, right? So that's what I mean, that they were indexing by the temperature right down there. And but we also have 1.2, and instead they've indexed by the pressure right there. So that's that one. And they have also have we have for the vapor one. This is the B.1.3, and that's the superheated vapor right there. And so let's get a little bit more familiar with these. And I think we will. All right, so we come down to B. Where's B? I lost you. There you go. All right, here's the SI tables, and let's see. Let's see what it is. 1.1, right? So this is 1.1 now. Saturated tables, and what they have to start with, they have the specific volume. So here, if you have the temperature and the pressure, you can find the volume, right? But if you but you notice they have V sub F and V sub G. This is fluid, saturated liquid, and this is gas, saturated vapor. And then here, I always think this was kind of funny because you don't really need this column, but it is kind of helpful because this column VG is really just this minus that, right? Look at the difference. You can see that because this is so small, those numbers are almost the same. But if you go down a little bit further and they get really close to each other, right? But these are nearly the same because this one is such a small number. So we want to be careful with our sig figs. Don't just get rid of sig figs, because you can see that like you need at least a bunch of decimal places to be able to get so that this thing actually matters. And then over here, we've talked a little bit about internal energy, but not much. But this is the internal energy. And once again, that is a function of the fluid and the gas, and the fluid minus the gas, or the gas minus the fluid. And we're going to use these three variables a lot. So especially when it's saturated liquids, which means it's in between a pure liquid and a pure vapor, right? It's in mixed phase. Scraping down some, we look again, and so we can see that there's a lot of values. I don't know if there's any necessarily that I want to point out to you. I didn't know that this got a 0 right there. That's interesting. At that temperature, let's see, is this still 1.1? Yeah, you want to explore this. Okay, so here's 1.2, B1, 2. And now we have pressure, and so we have on the left hand, we go down to even increments, and we have the corresponding temperature. So what we should see here for pressure, and these are absolute. This is absolute pressure, by the way. This is regular. This is not absolute temperature, but this is absolute pressure. So if we go down to 100 right here, we should see a temperature of nearly 100, right? Because this is 100 kPa, so 101.4, and so this should be close to 100. Let's go back. Actually, let's go back up to this table up here. It's worth looking at here, because here, yes, you go 100, and the temperature is the 101.3 for the pressure. And there's anything else that we wanted? Oh, let me double check something. I think maybe, yeah. Okay, so here's an important thing to note. I use these steam tables. There's an actual book, right? When I was actually, I still have them somewhere. I can't find these steam tables. I need to need to dig through some old boxes and see if I can find my steam tables. But anyway, on this page we had a specific volume and we had internal energy. But on the next page, notice that these indices are the same, or these indices, that these temperature and pressure, but now we have enthalpy and entropy, right? So there's 4 properties: specific volume, internal energy, enthalpy, and entropy, that we want to look at for these. Now we go to that page, you can see those are the same, and now we go up to 1.2, and these are all the same properties. It's just it's for our convenience. And then lastly, if we go a little bit further, I think it's the 1.3, yeah, B1.3. Here's the superheated steam, or it's actually superheated vapor water, I guess. I don't know why they don't call it steam. But you can see here's a different way of doing it. It's got the pressure here, and the pressure here, and the pressure here, and the pressure here, and then it's so forth. We have, just for 10 kPa, here's the temperature, and then here's our 4 properties: specific volume, internal energy, enthalpy, and entropy. And unfortunately, what you're going to have to learn to do and get really good at is something called interpolation. If you recall, you've probably done it before. I can show you a better way to do it. Every time I show students, they're like, I'm asking, have you ever seen it this way? And they're like, no. So I have a method of doing it that will be useful to you, and you won't even have to memorize it. It's easy. Well, you will memorize it right away, because it's just a common sense way to interpolate. But anyway, we'll have to interpolate a lot of things. And also, so you notice that there is no F and G, because there's no F, there's no fluid as part of this. It's completely gaseous, so we don't have to worry about it being a mixture, which leads me to the last part of this video. Maybe? Yes. Let's go ahead. So the last part of the video is to talk about, there's a little pretty colored picture thing. I forgot about that. That came out of the book. That's kind of pretty. It's kind of nice. It's talking about sublimation. Ooh, that's a good word. Sublimation, fusion are these different lines. Vaporization. Well, I know vaporization, but these other, I don't ever remember any of those lines, right? Where that's really sort of this boundary between is it solid? Is that what the S is? Yeah, I guess, yeah, solid and liquid. Huh, interesting. And there's some substances where this line leans to the left and it leans to the right, and others. I think I'm going to pick up this one in the next video. This is a really important idea. It gets used a lot. So we're going to cover what to do when you have two phases at the same time and trying to find properties. We'll talk soon.